This video will be about concentration units. First, what is concentration? Concentration is how much solute is dissolved in a given amount of solvent or solution. Think of it like tea. The longer that the tea bag is in the solution, the more solute, or tea, will dissolve into the hot water and the tea will be stronger. This is the concept of concentration. The tea particles are the solutes and the hot water is the solvent. When you mix them together, it makes a tea solution. A solution is a homogeneous mixture of two or more components. Since a solution is homogeneous, which means it is in a single phase and cannot be separated by physical means, the concentration is the same whether you have a lot or a little solution. The solute is the component that is in the lower quantity, and the solvent is the component that is in the greater quantity. There are many ways to express concentration. One of the most popular is molarity. Molarity is represented by a capital M, which is sometimes italicized. Molarity is the moles of solute dissolved in a liter of total volume of solution. The molarity unit equals moles of solute divided by liters of solution. Since there are 1,000 milliliters in a liter, molarity may also be expressed as moles of solute divided by 1,000 milliliters of solution. Let's work an example problem here with molarity. What is the molarity of a solution prepared by dissolving 3.50 grams of sodium chloride if the formula weight is 58.44 grams per mole in enough water to give 250.00 milliliters of solution? First, what are they asking you for? Molarity. Second, what kind of information do they give you to find this quantity? They give you an amount of grams, a formula weight of grams per mole, and a volume of solution in milliliters. Third, what else do you know? The definition of molarity is moles of solute divided by liters of solution. So you already know the denominator. It is the 250.00 milliliters divided by 1,000 to give you 0.25000 liters. To find the numerator, you will need to convert the grams they give you into moles. Fourth, how to find out what you don't know. Use the formula weight they give you as a conversion factor because its units are grams per mole. To find the number of moles of solute, take the number of grams of NaCl, 3.50 grams, and divide by the formula weight of 58.44 grams per mole to get 0.05989 moles of NaCl. To get the molarity, take the number of moles and divide by the volume of solution in liters. 0.05989 moles divided by 0.25000 liters, which equals 0.239 molar. Let's go over another example problem using molarity. How many grams of NaCl, if the formula weight is 58.44 grams per mole, contained in a 15.00 milliliter sample of a 2.50 molarity NaCl stock solution? First, what are they asking you to solve for? The amount of grams. Second, what kind of information do they give you to find this quantity? They give you a formula weight of grams per mole, a volume of solution in milliliters, and a molarity of the solution. Third, what do you know? The definition of molarity is moles of solute divided by liters of solution. So you already know the denominator. It is the 15.00 milliliters divided by 1,000 to give you 0.01500 liters. Fourth, how to find out what you don't know. We need to rearrange the molarity definition. To find the number of moles of solute, multiply the molarity, whose units are moles per liter, times the number of liters to get the number of moles. 2.50 molar times 0.01500 liters equals 0.0375 moles. Then use the formula weight they give you as a conversion factor because its units are grams per mole. To get the number of grams, multiply the number of moles calculated times the formula weight. 0.0375 moles times 58.44 grams per mole equals 2.19 grams. Another way to express concentration units is molality, which is moles of solute dissolved in a kilogram of solvent. Molality is represented by a lowercase m, which is sometimes italicized. Molality is expressed as moles of solute divided by kilograms of solvent. This is a little different than molarity because we are dividing by kilograms of solvent, not solution, like we do in molarity. This will come into play with our concentration conversions. Kilograms is a mass unit as well. An example problem involving molality is a solution containing 4.5 grams of potassium nitrate, KNO3, whose formula weight equals 101.10 grams per mole, is dissolved in 350.0 grams of water. What is the molality of the solution? First, what are they asking you for? Molality. Second, what kind of information do they give you to find this quantity? They give you an amount in grams of a solute, a formula weight of grams per mole, and an amount of solvent in grams. Third, what do you know? The definition of molality is moles of solute divided by kilograms of solvent. So you already know the denominator. It is the 350.00 grams divided by 1,000 to give you 0.35000 kilograms. To find the numerator, you will need to convert the grams they give you into moles. Fourth, how to find out what you don't know. Use the formula weight they give you as a conversion factor, because its units are grams per mole. To find the number of moles per solute, take the number of grams of potassium nitrate, 4.50 grams, and divide by the formula weight of 101.10 grams per mole to get 0.04451 moles of KNO3. To get the molality, use the definition and divide the number of moles by the kilograms of solvent. 0.04451 moles divided by 0.35000 kilograms, which equals 0.127 molal. There are other concentration units as well. Percent mass, which is represented by the percentage sign mass, is the percentage of the mass of a solute component in a given mass of solution. Percent mass of component A is the mass of component A divided by the total mass of solution times 100%. Notice that they do not give you a specific unit to put the numerator or denominator in. Just remember to put them in the same unit. So do not divide grams by kilograms and expect to get an accurate percent mass. A solution is prepared by dissolving 10.00 grams of sucrose, C12H22O11, which has a molecular weight of 342.3 grams per mole in 75.00 grams of water. Calculate the percent mass of sucrose in the solution. First, what are they asking you to solve for? Percent mass. Second, what kind of information did they give you to find this quantity? They give you an amount of grams of a solute, a formula weight of the solute in grams per mole, and an amount of solvent in grams. Third, what do you know? The definition of mass percent of component A is the mass of component A divided by the total mass of solution times 100%. So your component A is sucrose. So you already know the numerator. It is the 10.00 grams of sucrose. Let's leave the numbers in grams to find this answer. Fourth, how to find out what you don't know. To find the denominator, you will need to calculate the total grams of solution. But are masses additive? Yes, they are because of the law of conservation of mass. Mass can neither be created nor destroyed in a chemical or physical process. So to find the total mass, add together the mass of the solvent plus the mass of the solute. Take 75.00 grams of water and add 10.00 grams of sucrose, and you have 85.00 grams of solution. To find the percent mass, we use the definition of percent mass and divide the 10.00 grams of sucrose by the 85.00 grams of solution times 100%. This equals 11.76% sucrose. Mole fraction is another popular concentration unit. It is the fraction of the moles of a component of a solution to the total moles of all components in the solution. Mole fraction equals the moles of component A divided by the total moles of solution. Mole fraction is represented by a capital X with a subscript representing which component you are looking for. The component is important in mole fractions because for some problems you will be looking for the mole fraction of the solvent. A solution is prepared by dissolving 10.0 grams of naphthalene, C12H8, whose molecular weight equals 128.17 grams per mole, in 50.0 grams of cyclohexane, C6H12, whose molecular weight equals 84.16 grams per mole. Calculate the mole fraction of naphthalene and cyclohexane in the solution. First, what are they asking you to solve? Mole fraction of two different components. Second, what kind of information do they give you to find this quantity? They give you an amount in grams of both components of the solution and the molecular weight of both components. Third, what do you know? The definition of mole fraction is the moles of a specific component divided by the total moles of solution. Fourth, how to find out what you don't know. Use the molecular weights they give you as conversion factors because their units are grams per mole. To find the number of moles of naphthalene, take its number of grams, 10.0 grams, and divide by the molecular weight of naphthalene, 128.17 grams per mole, to get 0.07802 moles of naphthalene. To get the moles of cyclohexane, take its number of grams, 50.0 grams, and divide by its molecular weight of 84.16 grams per mole to get 0.5941 moles of cyclohexane. To find the denominator, you will need to calculate the total moles of solution. But are moles additive? Yes, they are for the same reasons that mass is additive. So to find the total number of moles, add together 0.07802 plus 0.5941 to get 0.6721 moles total. To find the mole fraction of naphthalene, divide the number of moles of naphthalene, 0.07802, by the total number of moles, 0.6721, to get a mole fraction of 0.116. To find the mole fraction of cyclohexane, divide the number of moles of cyclohexane, 0.5941, by the total number of moles, 0.6721, to get a mole fraction of 0.884. One thing to realize about mole fraction is that all components of a solution's mole fractions should add up to 1. This is a good way to check your answers. In our case, they do because 0.116 plus 0.884 equals 1. The last concentration unit you will be responsible to know about is parts per million or ppm, parts per billion or ppb, and parts per trillion or ppt. Parts per million is a dimensionless ratio of 1 part of solute per 1 million 10 to the 6 parts of solution. Parts per billion is a dimensionless ratio of 1 part of solute per 1 billion parts of solution, 10 to the 9. Parts per trillion is a dimensionless ratio of 1 part of solute per 1 trillion, 10 to the 12 parts of solution. Now you know all the basic concentration units, and you should have some experience with problems that involve them. The only way to master this material, however, is to practice the problems by yourself.